Welcome back. We are going to dive a little bit deeper into understanding all the parts of what makes a parabola. So I know we've visited this before in terms of just how to graph a parabola and finding the vertex, but we're taking this with a different approach because we are including the focus and directrix this time. So starting off, we're going to look at x squared equals 12y and just kind of look at the difference between this equation and your previous conic sections. You're going to want to notice that there's only one squared term in the equation. Most of the other conic sections, or I should say all of the other conic sections, always have two squared terms. So that's kind of a really big heads up that we have a parabola. And I know, they told us this in the directions, but sometimes we have to make that determination. The other thing you'll want to notice, and just ask yourself, is it the x term that's squared or is it the y term that's squared? And right now we have the x term is squared. So what that means is we're going to have a vertical parabola. And vertical parabolas, they either look like they're opening upwards or they are opening downwards. So those are the parabolas we've been mostly dealing with in this course so far. So a little bit of an idea is understand when you're kind of viewing the equations, you notice that we don't have any x minus h or y minus k. This is kind of a really big deal because they're going to tell us right away, or that lets us know that the vertex is at the origin. So not a bad idea if you want to plot the vertex now, might as well. So the next thing we want to find out is understand the relationship between the equation, the focus, and the directrix. So if we can go back and just kind of view the setup of how the equations are posed to us in this chapter, I'm going to write down the generic equation. And so remember, it's the x squared that's being x term that's being squared. Sorry about that. And the generic equation always looks like x squared equals 4 times p times y. And this is going to give us a nice idea of how to figure out who p actually is. So that is the first thing I want to do for myself, is I'm going to find what the distance is. So that's why I'm using absolute value. And that's always done by setting 4p. So kind of look at this, what we're looking at. It's the coefficient of the linear term. So set this equal to, in our case, it'll be 12. And we're going to deal with the negative sign if you want to just think about it now. If you do have a negative parabola, or negative term, you're going to have the parabola that faces downward. So we don't really have to deal with this at this point, as long as we understand how to make it work in the graph for us later. So again, we're just going to worry about the distances, so I don't have to worry about negatives. So we're going to set 4p equal to 12 from our equation, and that's where we got this. And then just solve for p. So divide by 4 on both sides, we're going to get p equals 3. So that's a distance, and that's really, really helpful to understand. Also understanding if we know the orientation of our parabola, we now could count to figure out where the directrix and focus are actually at. So just kind of another hint, if you have a downwards facing parabola, or it's opening downwards, the way your focus works is that it's located inside the concavity of the parabola, and your directrix is on the opposite end. So it's always kind of opposites here. So at this point, we could actually name what the focus is. We understand the orientation of our parabola, and I'm not going to, I'll erase this in a second, but we have something on this order, and I should probably be a little more precise. So we have something looking like this. I want to be a little more accurate, but I do understand that if I count 3 units down, That's going to be my focus point. And if I count 3 units up, that's going to give me the equation of the directrix. So I'm going to draw this with a dashed line. So I do have my directrix right here. So now that I have the graph, I will make the graph of the parabola a little bit nicer, but I can start naming what the focus is. So just by counting, the focus is located at the point 0, -3. And the directrix, remember, it's an equation of a line. So we have a horizontal line, so that's going to be y equals, and then it's crossing the y-axis at y equals +3. So we did find the vertex, we have the focus, we have the directrix, and the last thing to do is to graph this parabola. Now we do have an idea of what it looks like. We always kind of say you may want to find 2 other points on the graph. You can either do that by plugging y values or x values into the equation and solving for the other variable. But one of the shortcuts that I found, I like to use the lattice rectum. So what I like to do is figure out what is 2p. So I'll kind of give this a little hint here. So 2p, I calculate that really quick. That's the same thing as saying 2 times 3. So that's equal to absolute value of 6, which is just a 6. And what we're going to do is we're going to count 6 units away from the focus. And what that means is you already kind of know the orientation of your parabola. It's facing downwards. So the parabola should cross. It should be a horizontal counting that we take. So 6 units away. 1, 2, 3, 4, 5, 6, and then go the other way. 1, 2, 3, 4, 5, 6. That's going to give us a better idea of what the parabola looks like. So that means we have a wide parabola. And if you feel the need to, you can choose other points if you want more accuracy, but if you do use the lattice rectum, it does kind of help you out with how wide to make the parabola, and there's no real guessing there. So just kind of a reminder there if you're interested. So quick little count there. So 6 units to the left of the focus, 6 units to the right of the focus. And that's all there is to it. So there's a few things to memorize in terms of what it means when you find the actual value of p, or the distance. But please kind of always refer to your formulas to see if that also helps you as well. So that's kind of an idea of what happens when the vertex is at the origin. Let's do one more together and kind of look at your equation and kind of say, well, right now, our vertex is no longer located at the origin. So we're going to take a look at this, and you can compare it to one of the generic equations. I can write that out for you if you'd like. We have y minus k squared equals 4p times x minus h. And then that's kind of a heads up. If you all notice with me, you see that the y term is squared. And the x term is in a way linear. So that tells us right away that we're going to have ourselves, it's going to be a horizontal parabola. And I always like to write notes to myself as I'm doing this so I can kind of keep track. And just remember, horizontal parabolas, they can open up to the left, or I guess they'll be opening up to the right, or you could open up to the left. And a little bit of experience from graphing these in our past math courses tells us that when we don't see a negative sign in the equation anywhere, that's a coefficient of any of the terms, it appears that our parabola is actually going to be opening up to the right. That kind of helps you out with determining the direction. So now, having said that, we can kind of go into understanding what the vertex is. So remember the vertex, it's always h comma k, that's the value that's associated with the x term. So we're gonna have -4. And then the value that's associated with the y term, which is +3, the opposite of what we see. So we can plot that, -4 and +3. Helps me kind of label that that's my vertex. And now what I'm kind of understanding is I'm going to want to understand that I need to figure out who P is. So remember, it's kind of a quick little idea when we're comparing the equations. The 4P is always set as the coefficient of the linear term. So if we're going to find P, when we do that, we just set 4P equal to, in our case, it's going to be 8. And I'm going to be more precise. P is actually a distance, so I don't have to worry about opposites. Kind of helps me with less memorization later if I'm trying to really focus on formulas. If we solve for P, we end up getting P equals 2, or at least the distance is 2. So now if we understand how the focus relates to the directrix, we already know the orientation of our parabola. The focus will be located on the inside. The directrix will be a vertical line on the outside. So we're just saying what's the distance from our vertex to our focus point. That's going to be 2 units. So we have our focus right here. And then our directrix is also 2 units behind it, but this will be a vertical line. So you see, I don't do too much memorization with the formulas, but you can refer to the sheet if it helps you. I believe they're usually on your test, at least if you're in my class. So what I'm now looking at is just trying to figure out, let's name what the coordinates of the focus would be. And here I count from the origin. If I'm counting from the origin, it should be -2, +3. And the directrix equation, it is a vertical line, so it's going to be x equals, and then we just have to figure out where it crosses the x-axis. So that's crossing the x-axis at -6. So we have that taken care of. The very last step is to kind of have your nice graph of your parabola. And we already have a clue that it's opening up to the right. We just don't know how wide to make it. Sometimes it's narrow, sometimes it's wide. So this is where we pull the latus rectum back into the picture. That's my favorite way, but again, you can play around. If you like to just plug in points and find values, just make sure you're accurate and you find enough points. So again, we calculate what's the value of 2 times P. So that's leaving me with 2 times 2, which is the absolute value of 4. So that's a distance of 4 if you're interested. So what that means in terms of when we're plotting them, we should be counting up and down from the focus to figure out the width of our parabola. So we have 4 units up. 1, 2, 3, 4. There's a point on the parabola, and 4 units down from the focus. 1, 2, 3, 4. So now that's going to help us. So that was a little exaggerated. So let me help you out with that. There we go. That's really going to help us out with how wide to make our parabola. And just try to be symmetric. And if you feel like finding more points, great, but that is a pretty accurate graph. So I hope this helps. Take some time to practice. I know that focus and directrix is quite new to us. But once you kind of get the hang of it and how it's orientated with the parabola, these end up going quite fast. So I will see you in the next example.